And in our last example, we're going to take a look at putting all of the graphing together. So we're going to start by the domain. In this case, set the denominator not equal to 0. So we have a domain restriction, x cannot equal 1. To find any vertical asymptotes or holes, we want this in factored form to determine whether it's a vertical asymptote or whether it's a hole. So in our numerator, what multiplies to 1 adds to -1. No numbers do that. Our numerator doesn't factor it. Therefore, that denominator will not cancel. So x equals 1 will be a vertical asymptote instead of a hole. Do we have a horizontal asymptote? The degree, of course not, because we're focusing on slant asymptotes in this one, but the degree of the numerator is bigger than the degree of the denominator, so there is not a horizontal asymptote. It is 1 bigger than the degree of the denominator, so we're going to have a slant asymptote. I don't feel like I really gave myself enough room for the long division, so I'm going to start that over here. X times x gives us x squared. Changing the sign so that I can add instead of subtract, I get 0. And of course my remainder is 1, which we ignore, so my slant asymptote is y equals x. X-intercepts, set the numerator equal to 0. Well, we already determined it doesn't factor, so now we're going to have to use quadratic formula. Let me double check my signs on that to see if we have any real x-intercepts. So we have the opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2a. And under my radical, I have 1 minus 4, which is imaginary, so I have no real x-intercepts. To solve for y-intercepts, we substitute 0 in for all of our x's. So we would get, in the numerator, we would get 1. In the denominator, we get -1. So we get a y-intercept of 0, -1. I'm going to rewrite the function here so I can use it. X squared minus x plus 1 over x minus 1. So for symmetry, and then I scroll down too far, we substitute -x into the function and see what happens. Simplifying in the numerator, we get x squared plus x plus 1. In the denominator, we get -x minus 1. This is not the function we started with, so we're going to factor out a negative to see if the function has symmetry around the origin. Factoring it out of just the numerator, this is not the function we started with, so therefore it has no symmetry. Graphing what we do know, we had a vertical asymptote at x equals 1. We did not have a horizontal asymptote. We had a slant asymptote at y equals x. And we know that we have a y-intercept at 0, -1. With no symmetry, this isn't real helpful. I do know what's going on between the asymptotes. It's going to go something like this. So I can use the slant asymptotes that way, but I'm going to need to get a little bit more information to see what's going on off to the right. So I'm going to set up a quick t-chart using 2, 3, 4. So substituting 2 into our function, we get 2 squared is 4 minus 2 plus 1 all over 2 minus 1. So we get 3. Substituting 3, I have 9 minus 3 plus 1 over 2. So I get 7 halves. And substituting 4, I get 13 thirds. So when I plot those values, 2, 3, 7/2 is 3.5. That should be over one more right there. And 4, 13/3 is a little bit bigger than 4. So again, using my two asymptotes, I can get the other half of my graph. And again, I want you to focus on writing questions and a summary for your discussion tomorrow.